Swings! What are they? A seat suspended by ropes and chains on which someone may sit and swing in intervals of opposing direction.
But what is inertia? I don't care about stupid swings!
I'm glad you asked, little Timmy. Inertia is an object's tendency to sustain motion unless acted upon by an external force.
So why are you talking about swings, Big Joe?
Because swings accurately portray how external forces affect motion and momentum.
Oh, cool!
That's right, little Timmy, but how can we quantify this groundbreaking property of matter?
I don't know! I'm just a pure high schooler!
Well, little Timmy, we use the formula F equals ma, or mass multiplied by acceleration equals an object's force in newtons.
Big Joe, what does all mean? Like big newtons?
Well, little Timmy, newtons are a measure of force created by Isaac Newton. 1 newton is equal to the force of 1 apple.
Oh, that's cool! What about swings, though?
This allows you to move in a hemispherical shape, effectively creating a tangential force away from the curve of your motion.
Okay, Big Joe, let's look at that diagram!
Show me your newtons.
As we can see here, we have a diagram of a swing with points labeled A, B, and C. Each of these points represents a specific instant in which little Timmy may be located on a swing set. Let's say he starts off at point A. In this specific instant, his acceleration is equal to 0 and his velocity is also equal to 0. This means that Timmy has a force equal to 0 and his momentum is also equal to 0. Momentum is the quantification of an object's motion, modeling the object's tendency to maintain its movement against external force. It is equal to the product of an object's mass and velocity. We already know that Timmy's body has no momentum or force when it is at point A, but he does have potential energy, which is equal to the height above the ground multiplied by g, the gravitational constant acceleration, multiplied by Timmy's mass. This transfer of force and momentum to potential energy allows Timmy to experience weightlessness in instant A, but continue to fall down to point B and be carried to point C, in which the same scenario of point A is experienced. Timmy is subject to conservation of energy, and therefore conservation of momentum. All of this plays well with inertia as Timmy stays in motion, but slowly slows to a stop and constantly changes direction on the swing. Gravity and air resistance slow Timmy's movement on the swing, and at the moment that Timmy's vertical velocity cancels out with the gravitational constant, he changes direction and falls back to the earth in a tangential line from the curve of the swing. Timmy then remains in motion until gravity changes his direction and air resistance eventually slows him to a stop.